We, the team, which consists of Franz Kingston, Joel J, and Abhinesh RP, here to present to AI agent for groundwater management system using IBM Watsonx. So, we'll our motto is just address India's groundwater crisis using AI-driven solution. So this is a problem statement. So India faces a severe groundwater depletion, especially in urban areas like Bangalore. So we hear a lot of news like there is no water in Bangalore, so they are just um, standing in queues before water tanks and before water lorries so that they could get water. So the main reason is due to groundwater depletion. And also there are unregulated water excavation leads to scarcity which affects millions, right? Like we see in the news. So the government need an AI-powered tool to efficiently manage these resources so that they could just plan accordingly with all the factors so that they could um, effectively execute this plan to save water. So our solution is just create a groundwater management system using AI. So we just combined our innovation and intelligence with IBM Watson X so that we could just give a AI-driven solution for groundwater monitoring. So we just plan to integrate it with IoT sensors for groundwater maintenance continuously. Also satellite images for river monitoring as well as sometimes groundwater pollution and quality management. So also I just did some predictive analysis for water availability and resource optimization as to up to what the water will be available if this crisis exists and how we could just resolve it. And so we also give government policies and suggestions to take effective water conservation measurements. So this is a completeness and feasibility. So just give an AI analysis real-time groundwater data for better decision making and addressing water shortage in metro cities like Bangalore, Chennai, Delhi, etc. And so for this basic type of model, we didn't integrate IoT sensors and satellite, but in future we will just integrate it with IoT sensors and satellite images if government permits. We also try to deploy a model or a agent to help the government. So this align with government water policies for practical implementation. So our creativity and innovations comes with corrective water availability and optimization distribution. So our innovation is about real-time groundwater uh, prediction and real-time groundwater assessment so that this government could easily identify where we lack and what we can do to enhance the groundwater level. So we use IBM Watsonx for ML and NLP for policy recommendation. We also integrated like climate forecasts and IoT sensors and future and historical data like the Central Groundwater Board of India so that we could resolve this problem. So we also have few AI-driven platforms focuses on government advisories for groundwater. So our design and usability, we're just planning to create a user-friendly dashboard for policymakers and authorities, and we also tried to create an age-edited report and visual insight for non-technical users. So we in future also integrate web and mobile compatibility for mobile assessment and automatic notification for reports for proactive decision making. So finally, we also try to create a scalable system customizable for different regions. So talking about effectiveness and efficiency, so we just used only a small maybe simple ML models to get make the model simple and to avoid overfitting and underfitting of the model. We also optimize groundwater usage policies and detect depletion trends. So success, we are also success measuring the improved policy and better reservoir management, and we also um, expandable to multiple cities with additional data source if possible, and we are planning to collaborate with government agencies to ensure long-term impact. So finally, IA-driven solution is essential for tackling India's groundwater crisis. IBM Watson enables predictive analysis and smarter water management system. So we're just planning to collaborate with government for effective policy making, and we're just also planning for a scalable and adaptable solution for various regions. So this is a step towards sustainable groundwater consumption. So let us see a part of uh, a Jupyter notebook where we could see how this agent has been created, like what's an API key. So we use this agent to uh, integrate with all the documents which was given by the Central Groundwater Board, that is CGWB of India, and we just created with some parameters like frequency penalty, maximum tokens, etc. And so these are the code which we have just implemented, and so this markdown will have a um, mm, instruction for the AI model or AI agent to understand what all it should do and what all it should not do. And so this is how AI agent works. We just start with an AI agent. It integrates tool and gets the input and output from the user, and finally ends the model by giving them a good response. So this is output which we tried. Uh, so this is how the agent responses. So yeah, this is we just integrated XGBoost model, random forest model. So we use XGBoost model for predicting the groundwater level, and random forest model for predicting the quality of the groundwater, so that this even the groundwater quality plays a major role in groundwater crisis or groundwater level. So this is the graph uh, how the water level decreases, like groundwater level, and we just hope that the groundwater would be uh, increases if we just take some predictive measures. So let me show you how this chatbot works. So let us say give some suggestion to save groundwater in India accord- according to today. So here we click in it. Just wait for a response for some while. Yeah, so here we see the response, like it gives some ideas like rainwater harvesting, water effectiveness features, drip irrigation, crop selection, groundwater recharge, watershed management, and how it could be integrated, and like some um, acts of the government, like Atal Bhujal, Yotana, and like Pharma Participatory Action Research FPA. Yeah. These were some ideas which are given by the government the previous years, like 2024, 2023, in the documents. So this is a project, and in future we're just planning to integrate with satellite imageries, IoT sensors, and to create a useful dashboard, a web dashboard, so that the government would find it easy to used it in their daily life and improve the groundwater. So this is a project. Thank you so much.